Here's another example of how you can use similar figures for indirect measurements in finding distances. I want you to read and write this problem down in your notebook. Isaac is building a bridge across the lake on his new property. He needs to measure the distance across the lake in order to buy enough materials. Help him use indirect measurement to measure the distance across the lake. So there are some distances that he knows. He knows that from point A to point B is 320 meters. From point B to point C is 162 meters. And from B to D is 40 meters. And what he's looking for is this distance D across the lake. So if you will notice, he does have some triangles here. He has triangle ABD, and he also has triangle ACE. So let's go ahead and redraw these triangles. Let's take the big triangle first. That's triangle ACE, and let's go ahead and name those distances. So from C to E is D meters. That's what we're actually looking for. And from A to C, that would be 320 meters plus this 162 meters, which is going to be 482 meters. All right, so that was the big triangle. So now let's go ahead and draw this small triangle that is kind of laying on top of the big one. And we know that BD, here's B, D, and A. The measure of BD is 40 meters, and then the measure of AB is 320 meters. Notice up here again with AC on this big triangle, you had to combine these two lengths right here in order to get the whole length from A to C. All right, so now what we can do is actually set up a ratio table, because we know we have similar figures here, and we can use a ratio table to help us determine the unknown length of AD. So I'm going to set my ratio table up right here, and I'm just going to write triangle ACE, that's our large triangle, and triangle ABD, that's our small one. And you can name whatever you want. You can call it the big triangle, the small triangle, whatever. So we know that 482 here on the large triangle corresponds with 320. And then D corresponds with 40 meters on the small triangle. Make sure you have your ratio table set up correctly so that you'll get the correct measurements. Okay, I gave myself some more room. So let's start looking at relationships. We know that we need to get 480 down to D. So let's look at the relationship between 320 and 40. I don't see an immediate relationship this way, but I do see a relationship this way. What you might want to look at is 32 as compared to 4. How do you get 32 down to 4? You divide by 8. If you don't immediately see that relationship, then just start splitting things in half. That's also something that you can do. So let's go ahead and just divide 320 by 2. Well, 32 divided by 2 is 16, so that's 160. And then divide by 2 over here, that's going to be 241. All right, now it might be a little bit easier for us to see the relationship between 160 and 40. From 16 to 4, you can divide by 4. So 160 divided by 4 is 40. So over here, let's divide by 4 because we have a proportion. So 241 divided by 4 is 60 and 25/100ths. So the distance across the lake, or D, is 60.25 meters. Let me write that over here. D is 60.25 meters. So Isaac will need to buy enough material to cover 60¼ meters. All right, read this problem, write it down in your notebook as well. Peyton wants to ride her bike from her house to the park. She wants to first measure the distance that she will need to ride to make sure the park is not too far. So she wants to go from her house over here to the park. She looks at a map, but her map has not been updated with the new street that gives her the most direct route to the park. Help her use indirect measurement to find the distance from her house to the park. So this is the route that she wants to take from her house to the park. So it looks like she knows that from the light, the street light to the park is 5 meters, but what she doesn't know is how far it is from her house to the street light. It looks like maybe that was a new street. So she does know some of the measurements. So if we notice, we actually have a triangle here and a triangle here. So what we need to do is actually take this smaller triangle and reorient it, flip it around to where it matches up with this triangle here. So I'm going to take, let me do some erasing. I'm going to actually take Y. I'm gonna like kind of take this Z. The Z is going to stay the same. I'm going to take Y, flip it over here so that these angles, because they're congruent. So I want to take this and flip it over here so those angles lay on top of each other. And this angle actually flips over here. So in other words, if you can just imagine taking this, now watch, oops. All right, watch the small triangle. So I see how I flipped it over. So now 4 and 8 will be corresponding, and 5 will correspond to D. All right. So let me just redraw the smaller triangle right underneath here. So this is still going to be Z. Y now is up here, and W is down here. So this measures 4, and this measures 5. So now we can set up our table. Let's just, I don't know, let's call this the big triangle. That's a triangle. And then the little triangle. So the big triangle, let's go with 8, corresponds with 4 on the small triangle. And then D on the big triangle corresponds with 5 on the small triangle. And you should immediately be able to see this horizontal relationship, that 8 is split in half to get 4, or 4 is doubled to get 8. So we do times 2, so 5 times 2 is 10. So this distance right here is 10. Now, the question asked us to find the distance from her house to the park. So from her house to the park, this whole distance here would be 10 plus 5. So she is going to have to ride her bike 15 meters. Pause, rewind as much as you need. Make sure you understand this problem and you have it written down in your notebook, because you don't have a whisk again, but make sure you have them written down because you will need them in class.